Hello, in today's video, I am going to tell you guys why your child is struggling in math. This is the number one, the biggest reason as to why many kiddos are struggling in math across all grade levels. And I'm going to go ahead and tell you what you need to do and teach you guys exactly what steps you need to implement in order to end this math chaos and struggle. So, first of all, before we get started, I am a little stuffy. I'm just kind of getting over a little cold. I'm also not in my usual place. I am actually in Thailand right now, and I figured, a lot of people have been asking, so I decided to just finish up some dinner. Why not just, make a video, kind of help you guys out. So without kind of taking too long, let's just kind of jump straight into it. So very big reason as to why your kiddo is struggling when it comes to mathematics is because they are taught a certain way in school, and that is just not registering with them, right? So when the teacher is teaching, think about how many kids are in the classroom, right? Some of you guys, are fortunate and have small class sizes. Others, you might have a little bit of a larger class, right? But generally anywhere between about 15 to 30 is just kind of that big zone. But when the teacher is teaching, and I say this as a former teacher because this is how I taught. I was not teaching specifically directly to your kiddo. I was teaching in a broad zone, kind of like this little target kid was, whatever grade you're in, this is like the target audience. I'm just teaching to this. Now, if your kiddo is above this or below this, I'm not teaching to them specifically, right? I'm just teaching to here. And so when your kid is, and it's really hard for your kid to be exactly here, right? Maybe they're on grade level, and that's not the only component here. So a lot of kids are either above or below, right? So that kind of like has just like a little bit sliver up there. But now, let's say your kid is on grade level and you think you're good, right? Nope. Still, every kiddo has a different learning style. So that's kind of the other thing as teachers, and just kind of like the curriculum that's written, it does its best to be kind of a more like, holistic or comprehensive, and it just kind of hit every type of learner, every student, kind of have that. But again, it's just aiming for this zone, right? And some kiddos are a visual learner, right? Others, they're just a lot more hands-on. Everybody has a different style. Some kiddos are more numbers, right? And so this is what makes it really confusing is the curriculum has that in mind, and oftentimes almost every curriculum has 3 different ways of how to do something. So now it becomes even further, and I'm sure this is the frustration that you guys may have because I hear this a lot. Here's the math. This is how I learned how to do it, right? This is what the parents are telling me. This is how I learned to do it. But now in school, they're learning it a whole new way, and there's this confusing way, and there's this picture method way, and now there's just, all these different ways. And the purpose behind that is so that it hits all the different types of students, and it's giving, it starts with breaking it down with the visual. So it's giving like a picture, and just, again, area models and whatnot, photos, drawings, right? For this type of learner, to them to understand. And then the second type of learner is, the learner who is a little bit more concrete, and it's just the numbers, and it's just, more arithmetic, equations, expressions type of a thing, and it's just formula, right? So there we go. But then they have a third way, right? And then it just kind of, it's all this, it tries to get to every kiddo. But let's say your kiddo is, we'll just, for simplicity, we're just going to call it ABC type of learner. Let's say your kiddo is type A. They're going to understand A. But now when they're expected to also know B and C, it's going to go over their head. They're not going to understand. They're going to have a little bit of a harder time understanding it. So this is kind of the case. This is kind of like the big struggle as to why a lot of kids struggle, and it's just because it's being taught 3 different ways. So the thing is, there's something that you can actually do, and it's to kind of open up your kiddo's mind and get them to go from just this kind of closed, just tunnel vision type of this is how I think, this is how I learn, to start broadening it up and actually understanding why. Because it's not that you have to now learn how to be this kind of learner, and this kind of learner. You don't need to learn A, B, and C. If you are learner type A and let's just say visuals, for example, you do really well with visuals, you always need pictures, models, drawings, whatever, and that's how you learn and how you grasp, that's fine. But if you truly understand why, right? The why is the biggest part. If you truly understand the why we're doing what we're doing, then you can apply this knowledge, right? Once you learn how to apply it, that's kind of another step. It's kind of like first knowing why, second knowing how to apply. But just again, that just knowing why the math is done this way, why these numbers are doing whatever, then you can take that knowledge and you apply it to method B, method C, and it's going to make a lot more sense, right? Because now you genuinely understand the underlying reasoning, the foundations, the skill set. So this is huge. A lot of students, how we learn in school, it's because you're learning A, B, and C. There's all these different topics. Like one day, 1 week you're doing this, and the next week you're learning something new. A lot of these, a lot of students that I work with, they're all in survival mode. So what I teach them when I do academic coaching, in my private tutoring sessions, I really, really focus in the why we're doing what we're doing, right? Again, a lot of kiddos that we will work together and get that survival mode type of attitude where it's like, oh, I know how to do this. Don't you just do this or something and you do just whatever? And I'm like, yeah, but why? They can't answer it. They have no idea why. They can present the work. They've memorized the steps. They just kind of know that, well, we were dividing and then multiplying in class, so then now we got to divide and multiply for this or whatever. They just they're like, I just remembered how the teacher did it, so that's how I got the answer. They genuinely don't understand why. And this is why they make all the little mistakes, right? They make all the errors. They get a new type of problem. They're doing great. Then they get a new type of problem. And because they were in survival mode or because they just memorized what it was, now the new problem comes and they're just, I don't know how to do this. They immediately go into, I don't get this. I don't know how to do this. I've never seen this before. But when you genuinely understand why you're doing what you're doing, and I'll give an example in a second here, then they're going to be able to understand exactly what to do, right? So again, I specialize in middle school math. And so I'm going to go ahead and just kind of dive into that. But when you're solving for X, for example, and this applies to a great range, anywhere from like 6th grade up until high school and onwards. So I'm going to use this example. I think it would be a lot more suitable. But let's say you're solving for X, right? And so when you have just a very basic X plus whatever, now you have a number equals, when you just know that what you've done in class is just -7 on both sides, then that's what you're going to do, and you're going to get it right. And you're going to get all of those types of problems right, where it's just that one step. Oh, I'm so sorry. I'm going to go ahead and mute this. Where it's just that one type of problem, and it's just that, okay, sorry. It's just that one type of problem, and it's just that one step. They're going to know how to do it, right? Let's say you have a 2-step equation. Right now, you got to do -7, and then you're subtracting whatever that number is, and then you kind of are learning in class that you're subtracting, and then you're dividing, I guess. So they're just going to know that you subtract and divide. And they kind of get really good about learning, okay, well, you divide the number that's being plussed, and then you subtract the number that's being plussed, and then you divide the number that's being times. They just do that. That's all they do. They have no idea. But the minute you flip it, now the minute you give them something else, the minute you throw a subtraction instead of an addition piece, and the minute you have a fraction, or now you're dividing versus multiplying, they have no idea what to do. They're going to try to apply those same concepts and skills, and it's just not going to work, right? But when you explain to them that, listen, the reason why we're actually subtracting, I'll use that same example, the reason why we're doing -7 on both sides is because you've got this equation, and when you move things around, you've got the 7. We want to, first of all, you can't just make things disappear, right? If there's things, just like in real life, you can't just make things disappear. They have to go somewhere, right? So where you have to create balance, and the equal sign is kind of like where that line goes, and there's the two sides. So you got to create that balance. If you're going to do something, you want to move this over. The way to move, so let's say it's +7. The way to get rid of it is by doing the opposite. So you're going to do -7. Now, again, you have to go in and explain that, because it's just, they don't understand why you're doing -7. They're just like, okay, you do -7, get rid of it. But you genuinely have to explain, well, why do we do -7, right? And I typically ask them. I like to ask the students, and I'll go and make another video on this, but it's more, I like to ask the student, why did we do -7? A lot of times it's, I don't know, that's what my teacher did. So it's just really understanding that this is what creates balance. You're doing -7 to cancel out the +7. You've got +7, and when you do +7 -7, it's literally 0. So you've essentially crossed it out here, and now you have X by itself. You've crossed this out, and just kind of emphasizing that the whole entire goal is as solve for X. What's the question say? Kind of always referring back to the question. The question says solve for X. So then we are, again, why do we do -7? Because we're trying to solve for X. How do we solve for X? We get it by itself, okay? How do we get it by itself? Well, we got to get rid of that 7. How do we get rid of the 7? We do the opposite, and you get -7, and it cancels out, okay? Then you have to remember to do it to the other side, and so forth, right? Same with the multiplication. A lot of times when there's a coefficient with in front of the X, kids have no idea what to do, but when you kind of tell them, well, there's kind of a little hidden multiplication sign. When it says 2x, it's actually 2 times x. So what do we do? Right now, what's happening to the x? Let them come to that conclusion. Don't just tell them, let them answer. So start asking these guiding questions. Well, what do we have? We want x by itself. What's happening to the x right now? right? And maybe give them some options if they're really stuck. Give them those options. Are we adding? Are we subtracting? Are we multiplying or dividing? Right? So they're going to be like, oh, we're multiplying. Okay, well, what are we multiplying? We're multiplying 2 times x is what they're going to say, right? So then what's the opposite? We're doing times 2 to x right now. We want x by itself. How do we cross out the times 2? And again, divide by 2. Cool, awesome. And now they understand why. They understand why they're doing what they do. They understand the entire concept. And so throw them any other type of problem. You start throwing them exponents. You start throwing them square roots and whatnot. They're going to know exactly what they need to do because the concept, they understood the why. So now with anything, you've got something that's squared, you've got something that's division, you've got something that's whatever the case might be. They're going to know exactly what to do. They're going to know, okay, well, we're going to do the opposite. We want x by itself. That's what solve for x means get x by itself. We do that by doing the opposite. And it's all going to kind of tie together. So the more complex the problem gets, the less that frees up. I don't understand how to do this happens. So that is what I suggest. I highly recommend you start guiding your child and start giving them the guiding questions versus just teaching them how to do it, right? You can teach them how to do it, but that's exactly what the teacher's already doing in school. And I say this again as a former teacher. I taught completely differently than when I had to teach a big variety, of students at all different ranges and levels than what I do when I work with your kiddo in a small group or one-on-one. I definitely, make sure I implement it in this way, and the results are just amazing. The results, once they understand, they have that aha moment. They have like oh my gosh, I get this now. That's it. From then on, they're starting to understand, and slowly, the more you start doing this, all the different topics and concepts you start doing this to, it's going to build a really, really strong mathematical foundation, skill, and mindset with their perspective on how they approach. So then, all of this is just a snowball effect. They understand the why, they're training their brains, they're learning and looking at math a completely different way. Now you've got the next unit, because you've done all the work now, right? And this might take you a month, this might take you 2 months. Again, it just, there's really, because you've done you've laid the foundation, you've got that work done now, this is going to forever pay off. So whatever you end up, when you invest in your child, and you are pouring in that time and effort and sitting down and teaching them and giving them the scaffolds, you might stop one day and you might not be able to do that anymore, but that little bit of training that you've done right there is going to snowball, and it's going to continue year after year after year because they've learned how to properly look at math and how to properly think. How do I apply what I know to what I don't know? Why are we doing this? And just kind of all the little pieces. So again, that's my biggest advice. If you have any questions, feel free to reach out. If you are interested in kind of learning more, I am offering a free consultation. So again, if you just want to hop on a phone, you want to pick my brains, you want to talk to me about something, maybe you might either need my help or just want me to point you in the right direction, or perhaps you just need to vent and want some advice, link down below. Go ahead and schedule a free 30-minute consultation. I genuinely love just giving and helping, and just, again, the reason I created this entire YouTube channel was to share my knowledge, right? My whole thing is I want to impact as many students, as many parents, as many lives as I can with the information that I have. And there's just such simple ways as to, you can do exactly what I do in my coaching sessions. You can do this at home. If you sit down and spend the time, have your kiddo learn it a specific way, I promise you the results are going to be insane. You're going to have to just see for yourself. So till next time, don't forget to ask any questions. If you guys have any questions, you know how to reach out. Ask in the comments. Go ahead and follow me on Instagram and whatnot. That link down below if you are interested in that 30-minute little consultation, or you just want to pick my brains or whatnot. But other than that, I will see you guys in the next video.